on page 16, we're going to talk about box and whisker plots. We'll move on to scatter plots, which is the line of best fit that we did earlier in the year. And then we'll do something new, which is called quadratic curve of best fit. Okay, so you guys remember what a quadratic equation is? That's like a parabola, correct? So line of best fit would be for lines. Curve of best fit would be for a parabola. Okay, because you know a parabola is that U-shaped curve. So on this page here, when you guys did box and whisker plots, you identify the pieces to the box and whisker plot. Like the lowest number was called your lower extreme. Okay, the highest number here, the upper extreme. You guys remember that? Okay. This one right here, which is the beginning of the box, that's called your lower quartile. Sometimes it's also called the first quartile. So I'm going to put a first here as well. And in the middle of the box, and it doesn't necessarily have to be in the middle because it can be shifted to the left or to the right, but the line that's inside of the box is called the median. So that's like the middle number. And then this one right here is called your upper quartile. Sometimes you'll hear it called the third quartile. Okay, so write that in just in case they might switch from upper to third or lower and first. Okay, now there's also something called the interquartile range. We just abbreviate that IQR. Okay, so you'll need to write this down. How to get the interquartile range is you take your upper quartile, and I'm just going to say U for upper, Q for quartile, minus the lower quartile. So you just take this number, these two numbers here, and subtract them, and that gives you what we call the interquartile range. Okay. Now, you will not be asked to really make a box and whisker plot, and I will show you probably next class how you can actually make one right from the calculator. But as far as your SOL is concerned, you have to be able to interpret the information from a box and whisker plot. So you don't necessarily have to make it. But I will show you how you can construct one later, probably next class, on the graphing calculator. It's just kind of neat to see. Okay, it's very, very nice. So what you need to know, though, that each part of your box and whisker plot is broken down into percentages. So each percent, and really, guys, keep in mind, what does quartile mean? If I have a quarter, I have how much money? 25. So think of it as that. So each section is 25%. So that's 25 there, 25 here, 25 here, and 25 here. So each section is 25%. So you could have a question like how much of the data is between the first and third quartiles. So you have to know, what the lines represent, because they actually say lower quartile or first quartile. You have to know which piece of information you're looking at on the box, okay, or the whisker, depending on what they name it, okay. So let's go down, and again, we're going to skip the part where you construct it. We'll do that another time. We're going to have some questions that we're going to answer. It says, which measures a central tendency? Remember, these are called measures of central tendency. Which one of these can be calculated using the box and whisker shown above? And we're not going to calculate it, but we're just going to say which ones we could calculate. We cannot calculate the mean because you don't know each individual pieces of data. You just have certain numbers, like there's a number 10. Could be a number 50, depending if it was an even set and that just averaged to 50. And there's a number 110. Okay, those you can definitely say, I know that they're there. Okay, the other ones could be like an average of something. So I don't know how to find the mean from a box and whisker plot. I do know the median because it's right here. That's the median right there. We'll go ahead and put 50 for that because that's easy to do. I cannot tell the mode. I can't tell which sets of data are repeating most frequently. I can tell the range because I know this is the least number and the greatest number. So I have 110 minus 10, 100. Okay, so that's really what you can tell from there. Now I can do this. What percent of the numbers are from 10 to 30? Here's 10 here, here's 30 here. So this from here to here is what percent? 25%. Between 30 and 80. So here's 30, here's 80. So what percent is that? 50%. All you do is just count from, this is 25 and that's 25. And then greater than or equal to 30. Here's 30. So I got 25, 25, and 25. 75%. Okay? All right, so let's move on because we're not going to really stay on that a whole lot, but that's really the gist of what you'll have to be able to do. All right, now let's go back and review scatter plots. Okay, we've done line of best fits before. Okay, line of best fit. So what I'm going to have you guys do, and I'm not even going to put this up here on the board on the calculator because we've done this before. You're going to hit stat, and you're going to put in your L1 list, you're going to put the mill cost, and in the L2 list, you're going to put tip. Okay, so L1 and L2. Keep in mind, guys, L1 and L2 means this is your X value, this is your Y value. And that's going to be important to know once we get our equation, because we're going to be solving for different variables. So once you have your data in, you're going to do stat over to calc. We're going to do option 4. It's called linear regression. That's that AX plus B, which looks like MX plus B. Okay, and then you're just going to go ahead and hit enter several times until you come up with A and B. And then after you get A and B, we're going to write down what you have as our equation. Now, we want to round this to, let's round it 2 places out. Okay, so I want the slope 2 places out, and I want the y-intercept 2 places out. And then I'll ask someone what they have as an answer. Okay, who has an answer for me? All right, so what you should have is y equals 0.16x, and we got that right from the calculator, minus 0.3. Okay, so the whole purpose of getting this equation from the calculator is so you can make a very nice prediction. So here it's going to say if the dinner order meal costing, if the next in order is costing $10.50, how much should the tip be? So what you're going to do is, now keep in mind, this is meal cost. Okay, now this is the part that's very important, guys, so pay attention. This is the meal cost, which we label as X, that we put into our L1. This is tip, which is Y, which is in our L2. So when it asks for the meal costing, if the meal costs $10.50, meal cost is which variable? X variable. Okay, X. Then how much is the tip? The tip number variable is what? Y. So now the reason I point that out is you're not always substituting the value in for X, because the question could have said, if the tip is $2, how much did the meal cost? So then I would have been solving for what? X. So you got to pay close attention to the question, right? This one is asking for tip, so that's my Y. But if it had given you the tip and asked for the cost, then you would have been solving for X. So pay close attention to the question. So I can now then, since I know I can find Y on the calculator, I hit my Y equals key. I'm going to type in, and we can do it 2 ways. I'm going to actually type in Y equals, well, not the Y equals, but the 0.16x minus 0.3. Everybody type that into the Y equals. Hit your Y equals key, put in 0.16x minus 0.3. Okay. Now what you're going to do, you're going to change your table. So X is 10.5. How do we change the table to 10.5? Yes. Second window. All right, so you're going to do second window. You're going to change it to 10.5. Then go back to your table, and whatever the Y value is at the top, that's your answer. Who has the answer? All right, go ahead. 1.38, which is $1.38. Okay. Now, if I had asked you again, if I had given you $1.38 and you had to come up with the 1050, how would you have solved that then? Somebody tell me. Yes.
Okay.
Right. Then what I would have done is replace Y with $1.38, and then I would have solved the equation for what? For X. So just be very careful and don't always assume once you have this line of best fit answer that I'm always replacing the prediction in for X. You got to see how it's labeled. Okay. Let's go to the next question, please. Okay, we'll do one more of these, and then we're going to do some curve of best fit, because we've done line of best fit before. So go ahead and hit stat. And if you want to clear your list right from there, what do you hit after you hit, if you want to clear your list? Just like, let's just say I hit stat. That's all I've hit so far. What do I do? Yes. Option what? What clears your list? Option 4. You see that? Option 4. Okay, so now we're doing the exact same thing we did in example 1. Once you get your data in, stat, over to calc, option 4, enter until you see A and B. All right, give me the equation. Go ahead.
Y equals 6.08x plus 63.93.
63.93. All right. You can do 6.1. Same thing.
Yes.
All right, that's fine. Okay, that's close enough. All right, if you want to do 6.1x, it's okay. Now, here it says predict the exam grade of a student who studied for 6 hours. Okay. All right. So, 6 hours would be X or Y? X. So we're still plugging in for X right now. Okay, so you can type this in. You can go to your table where X is 6 in your table and see what the Y value is. Okay, and I think it's going to come out to 100. It might be 100 point something, but you should have okay. So that person, if they studied for 6 hours, I sure hope they would get 100 on the test, right? Okay, so that's what it comes out to be. You might even have a decimal, but we're going to just round it to 100. Okay. Go to the next page, and we're going to go to question 4. Okay. All right, so the height. And guys, this is what I would do every time I'm looking at like charts like this. I would always label the variables, X and Y. So you'll know when you get your equation, if they say shoe size, you know, like here, see how it says shoe size is 10.5? So that is plugging in the value for what? For Y, not X. So that's how you know which, when they give you this number, are you substituted in for X or Y? All right, so go ahead, hit stat, enter, put in your data again. Give you a second to do that. Wonderful. All right, so here's our equation. The question says if a man has a shoe size of 10.5, what would be his predicted height? So now we're looking for X. We're not looking for Y. So we can't just, punch it in the calculator this time. Okay, so this time we actually are going to go to a blank. Well, actually, we're going to write the equation down. So we're going to go ahead and go to on your paper, you're going to replace Y with 10.5 equals 0.42x, okay, minus 19.81. Okay, so you're going to solve that equation. So what are you going to do? Add the 19.81 to the other side. Is that right?
Yep.
All right. All right. So what are you going to end up with on the left? 30 what? 30.31. All right. And then we're going to divide that by 0.42. Is that right?
Yeah.
So what do you get?
72.1.
All right. So let's just say 72.117 inches. Okay. So can we round that to 0.2? All right, so let's round that to 72.2 inches. So how many feet is that? Divide that by, what's 72 divided by 12? 6, all right. So this person will be approximately about 6 feet 2 inches? Yeah, okay, all right. And that will, that's interesting, with a 10 and a half point, that would be a shoe size, 10 and a half. Person would be about a little over 6 feet. Okay. Interesting. Okay, so let's go to the next page. Now, notice the words are going to change this time. We're going to do 8 and 9. And what you're going to see is this word right here, or you might see this word right here. So this says quadratic relationship. So that means it's going to look like ax squared plus bx plus c. All right, so that means it's a parabola. So this time when you get your numbers off the calculator will give you 3 numbers. It's going to actually say the A number, it'll give you the B number, and it'll give you the C number. Okay, so go ahead and put in your data first. Okay, so go ahead, stat and enter, clear your list. Okay, put in your data. All right, so once you have your data in, we're going to go back to stat, over to calc. Everybody there? And look at your options. We're not doing line of best fit. We're doing quadratic. So which one says quad? Quad. It should be, well, we're going to be using 5. Okay, so the only difference is for line of best fit, you're going to be using option 4. For quad or curve of best fit, you're going to be using option what? 5. That's it. So everybody hit option 5. Okay, and hit enter several times like we've been doing before. And then it should look like this. A equals, B equals, C equals. How many people get A, B, and C? All right, did you guys get -3, 2, and 1?
Yes.
All right, so your equation then would look like this. Y equals -3x squared plus 2x plus 1. That's how you write your quadratic equation. So your A term is your A term, your B is your B, and your C is your C. Okay? And then you're going to do your predictions. It just simply asks you to find the Y value if X is 4. So you're just going to go to your Y equals and type this into your calculator. Go to the table where X is 4, and you're going to record what the Y value is. Everyone should get -39, so check it out. And then you're going to do the same thing for C. Now this time X is 1.5. Who knows how to change the value for X in the table again? You hit second what? Second window, type in 1.5. And the Y value should be -2.75. How many people found that? Okay, make sure you can do that, because we're going to do this one more time, but make sure you're getting those numbers. And again, just type in the Y equals -3x squared plus 2x plus 1, and then go to the table to get your Y values. Okay, it specifically asked you for the Y value, so there was no question we were looking for Y. Okay. All right, let's move on down to number 9. Number 9, I'm going to let you do on your own, and then I will check it with you. Okay, so go ahead and work that out. And you don't have to Just work it out, and then we'll come back together to get the answers. All right, I'm going to put the answers up here. You can check yours. You should have 46 for this one and 162 for that one. Okay? And this is what your equation should be. Y equals 2x squared plus 5x minus 6. How many people had that? All right, so that's the equation, and then you would just get the y values from the calculator, okay? Now, for your homework, you guys are doing starting at page 20 to 26, you're doing the odd numbers. Now, I'm going to start you off with this one here, because I do want you guys, because, you know, a lot of these are like practice SOL questions. I do want you to use some reasoning skills. Okay, so what do I mean by that? You know, some of this you can just say, okay, I'm looking at all of these dots. I always look, if it's multiple choice, to see if it's going in a positive direction or a negative direction. So these dots are going in what direction? Positive or negative? So it should have a negative slope. I'm not going to do any work, and I already see this is the only option that has a negative slope. And that's the only thing I did there. Okay, so some of this is just reasoning. It cannot be, well, yes, okay, I'm sorry, D also. But what do you notice about D as well? What kind of equation do we call this? Direct variation. Are these dots going to pass through 0, 0? So the only option it can be is B. And that's all I did, was just use what I know about linear equations. Okay? Now, this one over to the other side, you may not be able to do that reasoning like I just did on this side. Okay, but you can definitely, what I have done, or what I actually did, I actually wrote down these coordinates. Okay, unless you want to use a different reasoning skill, and put it into the L1 and L2 and see which one of these equations was very close to what I got on the calculator. Okay, that is definitely an option. Okay, so again, you're only doing the odd numbers, so please don't do the even numbers. Okay, we'll just stick to the odd numbers for right now.